Now let's discuss the sum rule. Now according to sum rule, if a task can be done either in one of n1 ways or in n2 ways, and if there is nothing common between n1 and n2, then there are n1 plus n2 ways to do the task. It's just like a disjoint set where we do not have anything common between n1 and n2. If we consider n1 as a set and n2 as a set, then it's saying that there are n1 plus n2 ways to do the task. So there is at the same time the condition that none of the sets of n1 way is the same as any of the, where none of the sets of n1 ways is the same as any of the n2 ways. Then there are n1 plus n2 ways to do the task. Now it will be more clear with an example, and then we'll try to represent it with sets, in terms of sets. Now let's have a look at this example. Department, the mathematics department has to choose a representative, and the representative can be chosen either from the faculty or from the students. So how many choices are there for this representative if there are 37 members of the mathematics faculty and 83 mathematics majors, and no one is both a faculty member and a student? So these two do not have anything in common, and at the same time there are 37 faculty members and 83 mathematics majors. So the total number of so this will be equal to 37 plus 83 according to the sum rule, since there is nothing common between them. So there will be 37 plus 83, which is equal to 120. These are the possible ways to pick. These are the number of possible ways to pick, choose a representative. Now, mathematically, or in terms of the sets, we can make sense of the sum rule, where we have two disjoint sets. A and B are disjoint sets. They do not have anything in common. So this is the universal set. We have A and we have B. They do not have anything in common. Then A union B is equal to A plus B. Or in other words, if we generalize this, so in a general way, if we have m number of disjoint sets, A1 union A2 union A3, so on to union of AM, this will be equal to A1 plus A2 plus A3, so on to AM. And here, since they are disjoint sets, therefore there is nothing common between AI and AJ. This is phi, and this is for all values of I and j. Now this is how this can be understood using the sets. So this is just like a disjoint set, and nothing is common between them. Now there are also cases where we combine the product rule and the sum rule. Now let's take a look at this example. It states that suppose statement labels in a programming language can be either a single letter, so it can be a single letter, which means we can choose from A to Z, or a letter followed by a digit. So we'll have plus here, which means this is a sum rule, or a letter followed by a digit. So first one is a letter, then second one is a digit. So in this case, again, we have A to Z choices, and the second one is a digit. So we have 0 to 9 choices. So find the number of possible labels. So this is a typical example where both the sum rule and the product rule can be used. Now to get an indication of how we can use a sum rule, here we have OR. And at first we have either a single letter or a letter followed by a digit. So this one, the first one, can be represented in 26 ways. Then the second part of this, which can be further divided into two tasks. Here we'll have 26 choices, and this for second digit will have 10 choices. So this will be equal to 26 times 10. So in total, the number of ways we can represent this is 26 plus 26 times 10. So this will be equal to 26 plus 260, and hence we can get 286 possibilities. So that was all about the sum rule and the cases where we can combine the sum and the product rule together.